So today you guys are going to be working on what is known as the Codon worksheet. So you'll see this little chart, and we talked about that in the video in class the other day. Within this particular worksheet, you guys are looking at DNA triplets, every 3 base pairs in DNA, messenger RNA codons, every 3 base pairs in messenger RNA, and tRNA anticodons, every 3 base pairs in tRNA. And that will also help you guys to decide or determine your amino acids, which you see on this table below. So remember, all the way around the outside is going to be your amino acids. So you have 20 different amino acids, so be careful. We talked about serine. Not only can you find it here, you can also find it over here. It actually has 6 codons that code for it. There's 64 different codons that are going to code for those 20 different amino acids. Also be aware that stop that you see here, those 3 codons, as well as this one here, they are not amino acids. They are your stop codons to say this is the end of my protein that you guys have. So below you have a little chart, and it's going to give you one piece of information there. So first thing that we're looking at this particular row that you guys see right here. Within that, what I'm looking at is right here. So I know that my messenger RNA codon is AAG, and I want to find my complementary DNA triplet. So what DNA made that messenger RNA? So you have to go back and go, okay, well, in DNA, I have adenine, thymine, guanine, cytosine. So I know that adenine in messenger RNA is going to go with thymine in DNA. So it should be TTC. Guanine and cytosine never change. So I know that this triplet is complementary to this messenger RNA codon. Now I have to figure out my transfer RNA codon. So in order to figure out transfer RNA, I know that transfer RNA is also complementary to my messenger RNA. So if I'm looking at messenger RNA and making it into transfer RNA, now my thymine has been replaced by uracil. So now my adenine here gets matched with uracil, cytosine. So cytosine you'll see in both DNA as well as your RNA. Now I need to figure out my amino acid, and this is where you guys mess it up. Do not go, oh, let me look up UUC. And I would go UUC, and it's phenylalanine. It's not phenylalanine. Transfer RNA brings in the appropriate amino acid. However, it is DNA's code that gave you what amino acid it is. But we're not looking at DNA. It's still in the nucleus. Who has DNA's code? Messenger RNA. So I have to utilize my messenger RNA in order to figure out my amino acid. First base pair is the largest letter in the middle, second base pair is the second ring, third base pair is the third ring. So I'm going to be looking up A, G, and my amino acid there is going to be lysine. What we say. So you guys are going to be going through and filling this in. You will see in some spots that maybe my DNA and my transfer RNA are exactly the same. So if we're looking here, GGC, let's make it into messenger RNA. G goes with C, G goes with C, C goes with G. Well, now let's do our transfer RNA. C goes with G, C goes with G, G goes with C. Oh, so my triplet and my tRNA are exactly the same. Yeah, they're both going to be complementary to my messenger RNA. If I go through, I'm looking up my amino acid. I'm looking up C, C, G. Here's C, here's C, here's G. My second amino acid is going to be proline. Okay, so that's how you guys are going through and you're filling in this complete chart. It's going to ask you guys a few questions down below. Be careful where I've highlighted the word all, because you're looking for the codons out of the chart that code for leucine. And just like serine, maybe leucine's in more than one location around that outside of that chart. What codons are going to code for these particular amino acids? Number 11 says, if the DNA sequence is this, here are my triplets, all the way through. So I have 1, 2, 3, 4, 5, 6 different triplets. What's my messenger RNA? Because remember, this is like my 3' end, my 5' end. The messenger RNA is getting made 5 to 3. What is my tRNA? And then what are my amino acids? So at the end, I should have 6 amino acids that you guys are stringing together that are going to be coding for by that DNA. Okay, so hopefully that helps you guys. If you have any questions, let me know.